Are you still balancing the equations using trial and error method? Then your time will be wasted and you will be confused. Why? Because balancing the chemical equations in trial and error method is involved with random guessing. But the random guessing may not give you a balanced equation in a short while. To get your equation balanced, instead of following the trial and error method, let's follow a simple method called algebraic method, where we can balance any chemical equation easily. For that, let's see, there are the steps involved in balancing the equation. For that, the step number 1, by taking an example where the iron is reacting with water to form iron oxide and evolving the hydrogen gas. Let's take this equation as our example and balance the equation in this algebraic method on fingertips. Let's see, in any chemical equation, for balancing it, we use the numbers. There are two types of numbers in any chemical equation. The first type of number is a coefficient, the number which preceding the formula in the equation. For example, if I assume A here, the A will tell you the coefficient of iron. Other than this, there is another number called a subscript. You can see there are different subscripts in the equation, like for example 2 is the subscript for hydrogen and 4 is the subscript for oxygen, 3 is the subscript for iron here and 2 is the subscript for hydrogen. If there is nothing, definitely the subscript is 1. To count the number of atoms in any equation, either reactant side or product side, we usually multiply the coefficient with the subscript for a given atom, which will give you the total number of atoms of that particular element. Now, using the same concept, we are going to balance the equations with a simple algebra. The first step which we have already followed is we wrote the skeletal equation. Now see here, to balance the equation, we are assigning the variables. What's meant by assigning the variables here? It's very simple. To balance the equation, we need to add the coefficients wherever they are necessary. Since we don't know the exact numbers right now, we are assuming the coefficient of each reactant and product with some alphabets. Now these are called variables. Now we can find the value of these variables with simple steps. How can we do that? That is by writing the algebraic equations. For that, first in this equation, let us consider iron as our atom now for our reference. Using that, left side, iron atom has coefficient A, subscript is 1. So 1 into A will give you the total number of iron atoms reactant side. When you come to the product side, the subscript for the iron is 3 and its coefficient is C. So 3 into C will tell you the number of iron atoms product side. Since we assumed the variables here, and after assigning the variables, this is the balanced equation now. So definitely 1A must be equal to 3C. Now in the same way, let's try with oxygen atom. Reactant side, here is the oxygen atom with a subscript 1 and the coefficient is B. So 1 into B will give you the number of oxygen atoms reactant side. Coming to the product side, 4 is the subscript, C is the coefficient, and 4 into C will give you the total number of oxygen atoms product side. which is equal to 1 into B. Now taking hydrogen atom, that is hydrogen element as our reference, if you write the algebraic equation, if you look here, subscript is 2 for hydrogen and its coefficient is B. Same product side, subscript is 2 and the coefficient is D. So these must be equal. Since balancing the equations, we are always intended to get simplest possible ratio, so we can give the relation between B and D as B is equals to D, as we can cancel the 2 either sides. Now we got some algebraic equations here. Now in a simple step, we can find the value of these A, B, C, D. For that, we are taking the LCM of the variables. How? See, this is 1B equals to 4C and 1A equals to 3C. Here, 1 is the number with B, 4 is the number with C. The LCM of 1 and 4, we know very well, is 4. In the same way, there are two numbers here, 1 and 3, whose LCM is 3. Now from this relation, what to do in the next step is simple. Write 1B is equals to 4 and 4C is equals to 4. Now from this relation, we get the value of B as 4 by 1, that is 4, and the value of C is equals to 4 by 4, which is equals to 1. So now we got the value of B 4 and we got the value of C as 1. Now from this relation, can we find any value? Same way, 1A should be equal to 3 and 3C must be equal to 3. So from this, we get the value of A as 3 by 1, that is equals to 3. And from here, we get the value of C 3 by 3, which is equals to 1, matching with the value. Now obviously, B is equals to D. Since the value of B is 4 we got here, definitely the value of D is also 4. Now from this, we got the value of A, which is equals to 3, the value of B, which is equals to 4, value of C, which is equal to 1, the value of D, which is equals to 4. Now if you plug these values in the equation, we will get the finally balanced equation easily. This is the simplest method to balance any chemical equation, where we have simple 5 steps. The first step, just write the skeletal equation, then assign the variables as coefficients, then write the algebraic equations by taking the different elements as reference, then finding the LCM and finding the values of variables, writing the finally balanced equation.